The last time I was in a symposium that followed Kathleen Jameson speaking, I listened to her talk about all the ways in which we speak poorly and end up creating problems of scientific communication. So when I gave my talk, I had an internal dialogue saying, oh my God, what did I just say? Did I just say that right? Is she mad at me? Is she judging me? Oh my God, she's judging me. So I'm going to try to be zen about that this time. Also, and this has been an amazing meeting. I appreciate the invitation. One of the disadvantages of going in the afternoon of the third day is that every other speaker's great talk already did everything I was going to say in my talk. It's been amazing to watch them. Last night I decided, okay, so what I can do that might be useful added value in the waning moments of the meeting is a step back of strategy. If all of the things we've been talking about, what the challenges are, what some potential solutions are, what some of the barriers to change are, how might we think about an integrated strategy to actually address some of these, actually shift the cultural landscape so that we can align the values that we have for science with the daily practice of how science gets done. And so that's what I want to focus on today. In particular, I was interested in the example that Susan Fisk raised of we've been here before. We've had a so-called crisis or multiple rounds of crises in psychology and then across research disciplines. So it's worth taking stock of how that went. And I have a different assessment of the last time that we were here in how that all went. So let me do that. Oops, it's not advancing for me. There we go. Oh, now it's advancing a lot. Let me back up. All right, now it's responding. So the last crisis can be characterized as happening in the 1960s, early 70s, and a number of issues that are familiar issues were raised. Research has too low power, there's too much flexibility in data analysis, people selectively report, and there's a file drawer problem with things being left out. Nulls particularly are getting ignored, there's a lack of replication, and there's significant misuse of statistics, particularly an overemphasis on null hypothesis significance testing and misinterpretation of p-values. Now, that's not just familiar, that is the same list of items that are of concern today. And if you go back and read from Sterling through Rosenthal, and these are only a sampling of the methodologists that were talking about these issues, you'll see that they identified, that you can read them as if you're reading them today. They identified what these issues were. They identified solutions like replication, like pre-registration, like more transparency, like open data. And so it is a very familiar discussion. But the particular things that came out of this that were the emphasis of what needed to change were increases in power, statistical power to detect effects, and more focus on effect size and decrease the emphasis of null hypothesis significance testing. So Jacob Cohen is most associated with suggesting the increase in power, and he did a review to say what was the average power of research in a sample from the early 1960s, and he found that the average power for a research finding was 0.46 in the literature, much too low, especially considering that almost all of the results were positive results, which doesn't make sense, because if you are investigating all true effects and you have an average power of 0.46, then you would expect a positive rate of 0.46, and yet 0.9 or 0.95 proportion of the articles were showing positive effects. Sedlmeier and Grigorenzer said, well, have we fixed it now in the 1980s? Because now that we know the problem and there was this whole crisis and now the crisis has passed, where are we? Average power 0.44 in their investigation. And every other investigation of power across disciplines has had a similar story. There has been a negligible change in the average power of studies, despite the awareness of the issue and calls for doing more. Jacob Cohen wrote two fabulous papers, 1990 and 92, sort of reflecting on his distinguished career. And you can see his quote here of just of sort of things aren't changing. And so mostly I just complain that things aren't changing, but we just have to be patient. They'll change eventually. The same is true for reporting of effect size. Susan mentioned that there is more reporting of effect size now, and it is true, there is more now. But in 2000, which is 40 years after the increased interest and saying it's important that we start reporting effect size and decrease reporting of statistical significance, a set of empirical reviews, this is a review of the reviews, suggested that there was virtually no change in reporting of effect size. And so their summary was a corpus of empirical studies of published articles, suggests that merely encouraging effect size reporting has not appreciably affected actual reporting practices. And their conclusion was you need to do more than just suggest and encourage, you actually have to require. Journal policies have to change in order for change to happen. And that has started to occur in the 21st century. This master's thesis by Sun in 2008 is the most recent evidence I have found on reporting of effect sizes. And by 2007, about 40% of articles in the sample of journals that Sun examined reported effect size. And that might be a little bit higher now. But that's not very high considering how long ago, right? How long do we need to wait for the culture to change on some of these things? So my view of that period was that the implementation, the identification of challenges was excellent. It's all of the things that we've been talking about, very rigorous research, but the implementation of change was ineffective. And so why was it ineffective? So there wasn't any kind of coordinated strategy. It was just researchers doing what researchers do and talking about what should change. But to the extent there was a strategy, you can identify three things that were active at the time. One was there was a lot of study about these issues. What is it that we need to change in our practices to improve the robustness of our literature? A second was that there was an emphasis on education and training. We need to know how to change. How do you report effect sizes? How do you do power calculations? Lots of books and information and training that is so that people know what to do. Third, there was a lot of work on inculcating those values, getting people to say, yes, this is something that we should change. We should be more open with our research. We should do power analyses. All of these may be necessary, but they're not on their own sufficient. And that's where I think the challenge was in actually turning this into daily practice. And what I think is different now is that a lot of the efforts that are happening across the research community are not stopping at these three, but instead are adding the additional features that make it sufficient to inculcate change. So what are those additions? One is infrastructure. We have to have the technologies to enable people to change their practices. Saying, share your data with everyone requires, where do I do that? How do I do that? What tools do I have to make that available? Pre-register your studies, well, how do I do that? Where do I do that? I need tools enabled to do those things. And then also the reward system, and this has been a common theme across many of the talks in this symposium, is to actually give people the incentives to embrace change. It isn't enough to want to change. You have to have the rewards in the system in order to enact that change. And so I want to focus on these latter two, recognizing that the incentives have already been discussed a lot, but talk about those incentives in terms of our approach to try to universalize them. And so what should change? And I want to make the case that it actually is very simple of what ultimately should change. There's lots of things that we've talked about different ways to improve research practices, and there are lots of things that can improve research practices. But I think if we do just two things, then all of that stuff will come along for the ride. And there are two things that both of my kids, and perhaps yours as well if you have them, learned in kindergarten. And that is show your work and share. And really, that's it. Show your work is be transparent in how you got to the claims that you got to. Share is be open. If people need your materials, share those materials. Your data, make that available to others. Transparency and openness are fundamental to enabling what we all talk about as the key part of what makes science great, which is self-correction. We can only self-correct if we know how to evaluate the evidence that we presently have. And if we don't have a full picture of the actual evidence, then we can't self-correct efficiently on it. And so Samin Vazir gives a great quote about this in her latest paper, creating an analogy with used car sales, is without data transparency, assessing a study is like buying a used car without being able to look under the hood. Right? And part of what the credibility challenge historically to the used car industry is that they can sell you lemons as soon as you get it off the lot, it's yours. And so as long as it looks good in the article, then it's fine for the purposes of getting the transaction that one wants, the reward of publication. But really, it's all of the stuff underneath. Victoria showed the quote by David Donahoe, right? The article is advertising for research, not the research itself, which is the same idea, is that it's really being able to see and then also being able to access to be able to extend or challenge the actual evidence that provides the basis for those research claims. So let me step back into trying to identify what are those sort of core values. In addition to openness, what are the things in which we identify as what researchers are trying to do as they do their research as a way to introduce some of the behavioral barriers to why it is hard to change a culture. So Robert Merton in the 1940s identified what he called the norms or the core values of what makes science distinct as an area of trying to acquire knowledge about the world. Right? One norm is communality, the open sharing of information. I don't just make a claim and you believe it, I show you the basis of evidence in order to evaluate that claim. Versus the counter norm of secrecy or being closed. Right? Universalism, research is evaluated based on its own merit rather than the reputation or authority particularism of who's making the claim. Disinterestedness, a researcher is motivated by knowledge and discovery versus treating science as a competition, just trying to get ahead of the person down the hall. Organized skepticism, a researcher considers all new evidence, even against their prior work, rather than organized dogmatism. I make my initial claims and then I spend my career fighting off the attackers of my claims to try to defend my theories. Right? And while Merton didn't talk about it, sociologists of science often raise quality as a norm as compared to quantity. So those might be easy to identify as general norms of science, but do researchers actually endorse them as things of how science should operate? And that's what Anderson and her colleagues did in a survey of about 3,300 NIH awardees. In this case, early careers referring to postdoctoral level. Mid-career are people who were in their first R01, which at that time was average age of around 40. What's showing here is just the survey results of whether they endorse the norms over the counter norms on average or vice versa. And in gray is endorsement of the norms over the counter norms on average. So more than 90% of early and mid-career researchers say that they believe, they endorse those norms of science more than the counter norms. And in black are those that say, no, I actually endorse the counter norms more than the norms. Very few people, right? And some give them equal weight in the slashes. So then Anderson and colleagues said, okay, that's fine. Don't tell me what you endorse. Tell me how you behave in your research. What do you do between them? And it looks like this. So still 60% or more of researchers are saying that they behave according to the norms of science, but many more are acknowledging that the counter norms also have weight, perhaps equal weight on their behavior, and still very few are saying that they behave according to the counter norms. They said, okay, don't tell me what you do. Tell me what all those other people in your field, what do they do in research? Right? Looks like this. So there is this profound gap in which the perception is, I believe the norms of science. I think this is the right way to do it. I try to behave by them, but I recognize this is a competitive atmosphere, and I'm not always living up to that. But everyone else around me, those folks, they are just in it for themselves. They're keeping material on their own. They're not sharing. They're defending their own theories. They're not behaving by the norms of science. This is a big barrier to change because it is a big difference between what you think the norms are in the community versus what you endorse as the norms for your own values. So how do I enact my values and behavior? Well, what I am confronted with is a choice. I can live by my values in science, at the cost of career advancement because everyone else is just doing things that will advance their career at the cost of good science, or I can behave according to how everyone else is doing it in order to survive in science. So that is a very difficult barrier to bridge because of the perception of the community not being aligned with my own values. So that's one barrier to individual change. Another barrier is what in psychology is called construal level theory. And that is, there's a lot of things that we're pursuing for the rewards of science, why we're in science in the first place, right? I'm curious, I want to discover things, I'd like to have an impact, I'd like to do important work. Those are all values and things of wanting to contribute to the research literature. And I need to get published and I need grants, right? There's a big difference between those two things. The first set of things, importance and impact and discovery, those are abstract and they're distal. It's hard to know when you've done them, and they're not very well defined, and you don't necessarily know for a long time. Whereas publication and grant is concrete and proximal. They are things that I know when I've done them, and they're the things facing me right now in order to achieve those broader, more abstract goals. The challenge, according to construal level theory, is that those concrete proximal things will almost always dominate decision-making when there's a conflict with the abstract distal things, right? Because they're right in front of you, they're facing you, they're the things that are gonna motivate your behavior because they're driving the decisions you're making day by day. That's another challenge. Third challenge is that we have these amazing frontal lobes that we get to employ in order to make sure the world looks like the way we want it to look. And so when we do research in my lab, we do many different studies. There's lots of different outcomes. Some of those studies present outcomes that are better for me in some way. They're more publishable, they're more exciting, they're more aligned with my ideology, my previous beliefs, my previous claims. What I'm easily able to do, without even realizing that I'm doing it, is reason why those studies that don't look as good for me, or those ways of analyzing the data don't quite align with how I want them to come out, are actually the wrong way to do it. And those studies that came out aligned with how I wanted and what I see and how I think are actually the right way to do things. And none of that need to be intentional at all. This is really just a repeat of Tina's amazing talk earlier this morning, is this core of motivated reasoning challenges. Fourth, you don't know what happens in my lab. All you see are the outputs that we present. And what we know about accountability is if I don't ever have the occasion to perspective take, think, would someone else watching me do this think that this is the right way to do it? Then I may be more likely to use those motivated reasonings, to just go with behavior that's better for me without even recognizing that if I took and looked at myself from a different perspective, that I might make different choices about how it is I do those things. And finally, I am busy, so are you. Right? We might have the values, we might have the desire, we might say, I don't care if my career slows down in the terms of rewards, I'm going to do it the right way. But now you're asking me to do more things, right? I need to make my data open, I need to pre-register. These sound like more work, and I'm really busy already. So how can I add that on to my research process and expect to get anything done at all, particularly given the competitiveness of the environment? Right? So any solutions have to appreciate the workflows that researchers have now and integrate with them rather than say, do these other things too, because that's really how to do good research. Okay, so those are some individual barriers, but those are all in the context of the fact that this is a big culture. And changing a culture is a lot more than trying to change individual behaviors. And there's two factors that haven't been considered enough in how it is that we shift a culture entirely, given the constraints that we have on human behavior. And that is one, the determinants of behavior, building on what we just were talking about. And the second is dealing with the fact that science is decentralized, that there isn't an authority. It's not that Marcia McNutt gets to say, okay, now we're all going to have open data. And everybody says, oh, okay, Marcia said we all have to have open data. We're doing it now. It doesn't work that way. There's a lot that has to... Oh, okay, sorry. I didn't know she was here. All right, but if you want to try, great, let's do it. Okay, so let's go into determinants of behavior. And this is really just a rehashing of Tina's talk, right? Our cartoon version of how human behaviors works is that we have values of how we want to behave. Those become intentions of how I'm going to behave, and then I have specific goals in order to enact those intentions. and then I do things. And sometimes that's true, right? I do have values and intentions and goals, and I try to use those to drive my behavior, but that's not everything that influences my behavior. As Tina described, there is a culture in which all of that is embedded, and a particular context in which my behavior is going to occur. And all of that puts constraint on what values come to mind, what intentions come to mind, what goals are relevant in order to succeed, and they put constraint on the extent to which the values that I have get enacted in my behavior every day. Likewise, and it is related, so this is a cartoon model, I would be embarrassing myself with psychologists to say this is my model of human behavior, but as a cartoon, there are also incentive systems, right? The direct things that I am rewarded for in that behavior, wherever their sources, culture, context, my intentions, or otherwise. So if we don't address those other two aspects, if we only rely on, let's get everyone to have the same values, teach them how to do it, and they'll do it right, they won't. And that's not because anybody is bad. Let's say everybody is good, but everybody is working and living under constraint. And the intentions that we have aren't the sole drivers of our behavior. And the core challenge that we think is embedded in this, and this has already come up in this discussion, so we don't need to have belabor this, is that the incentives for my success in the current culture are focused on me getting it published and not on me getting it right. Okay. So let's talk a little bit more about the decentralization of science, because this hasn't been discussed as much, and it's critically important, right? We know these things already, right? We live in knowledge silos. Each discipline has its own lingua, it has its own approach, it has its own infrastructure and tools and ways in which it does its work. And so there's lots of things happening that are the same challenges, but they're siloed. And so there isn't as much communication as there could be to enhance, to transmit, disseminate practices that are working versus practices that aren't. There are infrastructure silos. The tools that we use in order to get our research done, to store our data, whatever it is, are individualized and constrained, not scalable to the entire scientific community, because they're made idiosyncratic to particular uses rather than built with flexibility in mind to solve lots of problems. And the most critical part of this is that the incentive drivers are unique to the individual. So I have a certain set of institutions, a certain set of journals, a couple of funders, and a couple of societies that are the things that influence my behavior. But that particular constellation is probably unique to me. And every other person has a different combination of those because they are at a different institution. They use a couple of other kinds of journals. They work with different funders, whatever it is. And that is a huge problem, because what it creates is a coordination problem. There is no one point in the system that if we change that, all of the incentives for the culture change along with it. The coordination problem is that all of these communities have to move together, roughly, in order for the incentives for the culture to change. We might be able to change one individual's incentives in one slice of what they do, but because of decentralization, there has to be more coordination and communication in order to make it work. So any solution to solve that problem has to be both generalizable, applicable across these incentive drivers, knowledge domains, the different silos, in order to be applicable to them. And it has to be flexible, because there are some unique challenges. There are different words that people use. There are things that are unique to different situations, to be able to apply those things in terms of making them concrete and actionable. And so this is the focus that I want to make on the incentives that we have been trying to try to address this and maximize both this generalizability and flexibility in order to solve parts of the coordination problem. One of them has come up a lot already, which are the badges. And so I don't need to repeat what the badges are, because we've been talking about them, but just to say what is the core of the approach is to define something that is recognizable to any researcher. Right? The concept of open data is a generalizable concept. And so the specification of what it means to have open data in order to earn that badge is written in such a way to be context independent, or at least easy to revise to be context dependent, relevant to that researcher. Same with open materials. What are the units of how it is you do your research? If you do entirely simulation, your materials might be code only. If you do entirely wet lab work, there's a different set of materials, right? And pre-registration, same way. And as you saw this graph in David's talk and then some of the other discussions, a simple signal can be effective because it does something very easy, but does it in a way that draws on the values that people already have. We don't have to convince people of the values of open data. We have to make it in their interest to behave according to open data. And a badge is a very simple signal to say, if I have just had my article accepted at a journal and they say, do you want to earn an open data badge on your article? It'll say that the data are available in an independent repository and we'll provide a link. Then I just get to make a decision. Is it in my interest to signal that I have data available somewhere? Do I care enough about open data to make that signal? The journal has signaled to me that they care enough about it to offer me the badge. And so now I can signal back to the community that I care about it enough too to actually now do the behavior. And just that little incentive, just the ability to make surface, make clear, make evident to anyone that I'm actually doing a behavior that otherwise no one knows is being done because it's not evident anywhere, is enough to take data sharing rates in psychological science from 3% to 39% if they're consequential to this policy and badge change. Okay. A second has also come up a number of times, is the top guidelines, transparency and openness promotion. You can get more information at the website here. The key with the top guidelines is, again, working on this generalizability and flexibility model. So what the top guidelines are 8 separate standards. They're modular, so that some of these are more relevant in particular disciplines now than other ones. And by more relevant, it may only mean that the discussion has matured about some of these issues more in some places than others. Particularly, for example, pre-registration. There's some areas of science where that's an active discussion. People are considering it, demanding for it. And others where they say pre-registration, what are you talking about? You mean to the conference? No, it's about research. So the awareness of these can vary substantially across disciplines. And so the top guidelines are modularized so that any given journal or funder that wants to adopt them just adopts the ones that they want to adopt. And each of them have 3 levels of stringency, from disclosure to a requirement to actual verification that the authors followed through or the grantees followed through with that. And so that flexibility in both level of stringency and adoption of different standards provides enough flexibility so that they are universally adoptable, while simultaneously establishing a standard that can be applied across the different incentive holders that inform me as a researcher or inform anybody else. And so that's a key aspect of the guidelines, and that is a big part, I think, in why they've so far been relatively successful in gaining adoption across research disciplines. So far we have 757 journal signatories, 63 different organizations that have signed on. Okay, a little bit of research introduction before the last one. Again, this is familiar, but Kuhn and many other philosophers of science have talked about 2 modes of the research process, and this has come up in this discussion. One is the context of justification. I have a theory, I have a set of hypotheses, I want to do a study in order to confront that hypothesis, to test that hypothesis, in order to confirm or dispute whether or not my hypothesis is retainable given the evidence. The work that's done in that confirmatory mode of analysis is data independent. I need to specify what my hypothesis is. I have to specify what the design is that will test it, and I have to specify the analysis that I'll do in order to evaluate that hypothesis without knowing what the data are, so that the data can become an actual test of the hypothesis. Right? The other phase of research is the context of discovery, where I'm in the data and using it in order to generate possibilities. Right? I can't anticipate everything in advance, so lots of the work that happens in my lab is done after the study is over, and we look at the data and say, what about this, what about that? Oh, let's put these covariates in, what happens here? And a lot of that then generates what it is we think we might do next. The role of pre-registration is one single function, and that is to make clear when you're doing one of these or the other. It's not to value one versus the other, it's simply to make them distinct from one another. So with pre-registration, I can identify what are my confirmatory tests. Am I actually testing hypotheses with this study, or is it purely exploratory? And if there are any hypotheses that I actually am doing the study in order to test, then a pre-registration helps identify that. The value of this is that the p-values, the tools of statistical inference, are interpretable in the context of justification. If I have put constraint on knowing what my analyses are before I do the analysis, then those p-values have their diagnostic value. As soon as I'm in the data, and the data is informing how it is I then further examine the data, the p-values lose their diagnosticity. I don't know how to interpret them numerically because I have entered the garden of forking paths, as Andrew Gelman describes it. So the reason that distinguishing these is so important is that presenting exploratory results as confirmatory can increase the publishability because we can be pulling noise, thinking that noise is signal, but at the cost of the credibility of those results. And so how does pre-registration work in practice in exploratory modes of science? Well, we now pre-register everything that we do in our lab, and it follows a common form, right? We have some reason that we're doing the study, so we write down what is that reason in advance. Write down how we're going to analyze the data. We do the study, and immediately after we analyze the data that way, we enter exploratory mode with those data. Say, well, what did we not anticipate? You know, we don't really know much about this domain yet. We had just a really simple initial idea, so let's really dig in to that data and see what we learn in order to refine the method, to improve our process, to see what we might do next, and that informs the pre-registration for the next study. And we go back and forth and back and forth and back and forth. Okay, this is an unfamiliar process in basic and preclinical sciences. There have been instances of it, but it is not common or universal, and there's lots of reasons we could get into about that. But we wanted to try to do something that gets people started with it. And so we launched the pre-registration challenge, which is really an awareness and education campaign. What it is $1,000, $1,000 awards to researchers that publish the results of a pre-registered study. And for us, it's a way to get them in the door to learn about what is pre-registration, how does it work, and then it has a guided workflow to try to lower the barrier of entry to get people started on thinking about doing pre-registration. And this ties closely to another intervention that has come up in discussion, which is the model of registered reports. And you've heard about this already. The basic principle is to move peer review from after the report has been written, where all the incentives for me as the author are make that report as beautiful, interesting, and innovative as possible, but the evaluation is results contingent. It's really the results that have to be as beautiful and interesting and innovative as possible. And move the peer review to after the design phase, where the emphasis of the incentives are ask the most important question and develop the most compelling methodology you can to test that question. And then we don't yet know the results. And so this has interesting implications for many of the incentives that drive researchers' behaviors. Right? For the researcher, if I'm focused at the report stage, then my interest is in getting beautiful results. Here, I'm interested in asking important questions and doing good methodology to test it. Likewise, for reviewers, the incentives change. At the report phase, when I get a paper to review, if it has findings that are consistent with things I've claimed, I find the methodology very compelling. If it has outcomes that are inconsistent with things I've claimed, I find lots of problems in the methodology, right? So I have skin in the game as a reviewer if I know what the outcomes of the research are. If I don't know the outcomes, and I'm helping to design the study that will evaluate, test a claim that I've made, then my incentives are make it the best test possible. And anything I identify actually has productive value in the research process, because when I identify problems at the report phase, all I'm telling the authors is you screwed this up. The study stinks. At the design phase, when I give feedback and say, oh, what about this, what about that, then they can actually incorporate that. And so as an author doing register reports, I am grateful to the reviewers for all of that critical feedback because it improves the robustness of the design. There's a lot more to say about the register reports, but there are 49 journals so far that are trying this out, and it has been a very interesting impact. We can discuss it more during the discussion period. Okay, so that's on incentives. What we haven't talked at all about at this meeting, which is really the core of what most of the Center for Open Science does, is developing infrastructure to try to support the entire research lifecycle. So I wanted to try to spend the last few minutes that I had to say a little bit about our infrastructure strategy and would welcome your feedback. The Center for Open Science is a nonprofit. We have no monetization at all, so everything that's built is free open source tools, because all of it is supposed to be public goods infrastructure, trying to provide tools that make it easier for researchers to get around their research life cycle and make that research life cycle more recoverable, more reproducible, more transparent. So I'll give you sort of a general view of what that infrastructure is. And really, it's about 2/3 of our team. So we have a staff of 75 now, 55 full-time and interns. 2/3 of that staff is software team. So mostly what we work on is this. But it's 3 layers of infrastructure. And at the base is what we've been spending the most time on the last 4 years, which is the Open Science Framework. And it's a set of 3 tools. The services are a modular set of tools, composable tools, that do things that websites need to do, data repositories need to do. Any kind of infrastructure that sort of supports the scientific communication process needs to have file storage, needs to have ways to render the files, needs to have security, needs to have ways to authenticate users to get into or out of the system, needs to have tools for search. How do you find stuff in there? All of those tools are designed as composable units that can be put together, built into any kind of service. There's an ecosystem I'll say more about of integrated services in a minute. And then there's the shared data. The shared data is a collaboration with the Association of Research Libraries, which is creating a single open data set of all research events, whether it's a publication or a preprint or a grant data set, anything that is a research output. We have a normalizing process that takes all of those different sources from everywhere and puts it into a single open data set in order to be able to do more search and discovery on that data set and potentially curate to link that person with that data set, with that publication, with that retraction, whatever. So that base layer is independent of the interfaces, how you engage with that scholarly commons down there. And those interfaces can be built to serve particular needs around the research lifecycle that have independent workflows. So the thing that I do when I'm creating my data versus when I'm analyzing it versus when I'm sharing it in a preprint service versus when I'm registering it, those all have unique workflows, but they're all connected to that same core infrastructure, the same core data and scholarly tools to manage me going around that research process. So those interfaces are independent ways to work with the same root stuff. And all of those interfaces can be branded for communities to operate themselves. So we create general interfaces and then give those to communities that want to start their own service of that kind. And so I'll tell you a little bit more about that. So here is the life cycle of connecting these tools and services. So there's a variety of different tools. At the core of the OSF is an API, where if a service is connected to that API, then it's connected to all the other services that are already connected to the OSF. These are the ones that are done now, and these are ones that are in development. So the idea is solve a problem that researchers have now. Give them a place in the cloud to store their stuff and archive it. Make it easier for them to get around their research lifecycle so that they benefit from doing this service, right? Don't add work to them, save them work. But then by connecting all of these services together, it makes it a lot easier to make that entire research life cycle more reproducible. So the main interface that we have is the OSF, osf.io. It's a project management system. You go in, you log in, you create projects, you add collaborators to those projects, you put your data and materials in those projects, you can register those projects. It's managing your internal workflow for your lab privately for as long as you want. You don't have to make anything available. But you can make any parts of it that you want public by just clicking a button and saying, yep, I'm really sure, and then clicking it again, and then that stuff is publicly available. So it integrates public and private workflows in order to maximize the ease with which people can go more transparent in their research. And that can be branded for institutions, and institutions can connect their own tools, their own internal repository, the ways in their computational services that they may have at their institution, so that they can make it easier for their own researchers to get access to their own tools. And so these are the institutions that are already working with the framework. Finally, just I want to stop so there are time for questions, but I'll just give one more example of an interface, which is using that same set of tools. We created a preprint interface, which is specifically for depositing or discovering preprints. And there's a variety of preprint services now that are using that interface. 5 of those have been released. The other ones are in development. So the default interface is just OSF preprints, and it has a easy workflow for adding preprints, and then has a discovery layer that integrates preprints from any service that we can get connected to the OSF through that shared data. So you can have one place to discover preprints from anywhere. But then that service can be branded easily for other communities to run and operate and govern themselves, to make it really efficient for them to work on and innovate and experiment with different norms about how preprints should work in their community, but foster interactivity across communities, reduce the siloing by providing public good infrastructure, shared infrastructure, for them all to experiment with each other. Okay, we do the same thing for registries, but we are at time. So I'll just close saying that our ultimate goal organizationally is to establish openness as the default, whether that's the outcomes of the research, the publications, the findings at the end, the content, data, materials, code, and everything else, and the workflow, how it is that we got to that discovery. And by opening all of that, we give ourselves the opportunity to actually self-correct by critiquing and putting that stuff into the marketplace of ideas, which is how science is supposed to operate anyway. So thanks very much for your attention.